SatHub, who are responsible for software development for things like predicting passes of satellites and other software. And we also have them working on things like observations. So they have both, they take observations, and just today they're going to tell you about the announcement of a new paper. I won't give away the punchline that just came out from one set of observations that the network did. And then, and also they have a depository for observations. So they're going to tell you all about all the projects that are going on and all the contributed papers as well. So Siegfried and Mike.
Thank you very much, Connie. Thank you so much for coming to the first setup session of today. This is going to be about the impact of satellite constellations on radio astronomy. And I am Siegfried Eggl. I'm at IAUS. I'm also co-lead of the IAUS CPS SatHub. And it is my pleasure to introduce another co-lead of the IAUS CPS SatHub, Mike Peel, who is going to give us the first talk on SatHub.
So hi all, I'm going to try to be quite brief because I want to get us onto the main session as quickly as possible, but this is going to be kind of an overview of CPS and SatHub and a few teasers of what will be coming a bit later on in the other talks. So if someone could put my slides up would be nice, please. No, it's Codeburn needs to turn it on.
Because they're all done from here. That's why. They're all done from here. So
No, they're not. This one isn't.
No, they don't do it from there. They do it from here.
It's sharing on Zoom, same as the online. It's sharing on Zoom directly, so they need to put Zoom on. Sorry about this. I could just turn my laptop around, you can see it on there. It's sharing on Zoom, it's just not showing in here. No, I'm sharing by Zoom.
Ah, you're sharing by Zoom.
Yes, okay. Same as online, should work. The link to my slides if you want.
Yeah, I don't have it right now, but they are putting out right now.
Okay.
You have it.
It's on. It's on. Okay, great. It's not showing down there, but it's up there. Good. So to give us some briefly what SatHub is, the idea is it's kind of the executive arm of the IAUS CPS. It's a public, community-driven, coordinated hub, and it's trying to basically the overview of the observations and the astronomy side. With optical data repositories, orbital solutions, software tools, and also training. And a big part of this is collaboration online on the Slack channels. This is all still under construction, so things may change over time as needed. So this was the original summary from the SatCon 2 slides, which document which summarised the aim of SatHub, and we're turning it into reality, so things will change a bit over time. So the people involved in SatHub is Meredith Rawls, who is at University of Washington. She's remote today for the whole conference. In fact, myself from Imperial College London, Siegfried from University of Illinois, and we also now have Michelle, who is in the room, who is a software developer at Noir Lab. So if you have any questions anytime, these are the people to ask. One of the things we've been working on is having a data repository and exchange. So the idea is basically there's so many observations going on which are getting satellites. People don't know necessarily what to do with the data. We want it because it's really interesting for us. They don't want it because it's bad for them. So try to have a central place where people can share, submit their observations contaminated by satellites, so we can use that for understanding the satellites themselves. So the idea is we have a system for submitting and retrieving the brightness measurements. These can be anything from visual. We have visual observers who look at the stars next to satellites going past, do a visual comparison, and get very well calibrated optical magnitudes, which is really impressive. So we've been capturing those as well as optical telescopes observations and others, as well as near infrared. So we're working on those at the moment. We also want to expand this to look at spectra and radio data, which is future work. So where you see things in green here, they are pretty much done and running. Where they are yellow, they are in progress. And where they are red, it's in the future. We will get to it at some point. A key part of SatHub is we want contributions from everyone. So if you are observing at the moment with satellites, please do share your observing campaign plans and data with us. It will be really useful. We aim to have the easy-to-use interfaces up soon. And we also welcome software developers and contributors. Please contact us at that address if you're interested in that. Another key thing we're working on at the moment is Orbital Solutions Portal. So as well as needing the brightness, we need to know the position of these satellites so we can accurately measure them and understand them. And that's not something that's easy to do because you get two-line elements describing the orbital parameters. They need converting to the positions that you are at for the observers. They regularly get updated. So currently Starlink issues TLEs every 8 hours. Others release them less quickly. And it's important to make sure you're using the latest TLEs because the orbits do change of these satellites. So Michelle has been working on a API which will enable you to do this. So you request where you want, which satellite you want to observe and when you want to observe it, and you get the positions from your observatory. We also want to add uncertainties into this, which is important, so you know how accurate the positions actually are. And the plan is to use multiple backends for the sources of these TLEs. So Celestrack, which is already online, and there's companies like Privateer and others who are, have access to other sets of data, which we also want to integrate in this and try to give multiple options for positions and an estimate of how accurate they will be for you. Something that we really want to do is looking back to the history of all TLEs. So from the radio side, we have surveys which last many years. We want to go back through that data and understand where the satellites were, and that's not easily done at the moment. You can find out where they will be, but not so much backwards forecast. That requires a big archive of all the TLEs, and we have a funding request in to be able to do this in the future. Some things we need here is really better data from the industry. So we want better orbital parameters in more timely manner. And we're also hoping astronomers can help check these orbits are accurate. So I'll come on to a part of that a bit later on. Another thing we're kind of starting to work on is software tools. So Past Predict, Trail Mask and things which are all mentioned in the SATCON 2 documents. And these are still very much in development. We want to make sure they're properly documented and with standard test suites. So if anyone who's a developer here would be interested in working on this, we'd really appreciate your help. The idea is it's all open source and collaboratively developed. One other thing we're doing is we have a software survey that's currently running. So we're aware there's lots of existing tools out there which are doing very useful things, but we don't necessarily all know about them. So the aim is to try to gather all of these, to have documentation in one place for describing all of these, avoid having duplication where people develop the same tools again and again, and avoid us actually doing the same. So we don't want to recreate what's already out there. We want to point people towards the best tools to use. So this is currently running. There's a Google form link there. I'll put that on the Slack later as well. So please do fill that in. The aim is to have that being input into the hackathon we have on Friday. So if you look on the schedule for Friday, we have parallel sessions, and one of those is a SatHub hackathon, which will be in the museum just down the road, where if you want to come and work on some software tools directly, you'll be very, very welcome to that. The key thing, I think, for SatHub is that we have real-time communication going on. So we have the SatHub channel on the IAUS CPS Slack, which if you're a CPS member, you should have access to that. And that's quite an active place where we're trying to share information at the moment. So please do participate in that and share information there. We have a GitHub organization where we're putting the new software that SatHub's been developing. We're also welcoming anyone else that wants to use that for their own software to raise awareness of it and to share it within SatHub. We're aiming to write documentation, follows the Write the Docs best practices, and we do have a plan for a sathub.org website that will be coming soon. One other thing to mention is that we have a service which is a paper review process. So if you're submitting a paper which is related to satellites, please do submit it to us so we know about it to start with. But then we also give free peer review within 2 weeks. We've just been doing this with an optical paper to be coming out soon. It's quite a useful process and it's free. So it's something I'd encourage you to look at. And please do join in on the discussions on the Slack. Do share your code and come to the hackathon. I'm guessing we're running out of time. I don't want to say too much about this, but I can't not present about satellites and not talk about radio astronomy because I'm a radio astronomer. So one thing I'm particularly interested in seeing is understanding the impact on radio astronomy. I think some of the talks in this session will highlight some of this. Kind of an overall summary is we don't really know much yet. We need really observations to assess the actual impact that satellites have on radio, because we know they have active transmissions, we know they have unintended emissions, we don't know about side lobe coupling, which is important for CMB experiments. It's difficult to filter out unless you've got very expensive FPGAs on your system, and it's also very variable. And I think this is probably one of the best illustrations we've got of the problem in radio astronomy. So this is from Cote experiment, where you see the sun at the top in the galactic plane. You see a lot of geostationary satellites as bright as the sun. And also in this case, you saw some side lobes way out from the satellites. They were removed by putting baffles on the telescope. But the risk is you have this geostationary band now everywhere in the sky because of low Earth orbit satellites. So we really do need to understand this. We also have been doing observing campaigns. So this is Blue Walker 3. This is a video of it. It was shared with us. You can see just how bright it is. And there is a Starlink satellite top right now. So you can see just how bright it is in comparison to that. And there was also a lovely photo that someone took from the ground, which actually shows Blue Walker 3 satellite. You can see the phased array. You can see the central satellite body in that. So that was impressive to see and a bit scary. So the news is that we have a Nature paper that came out yesterday evening. So this is the observing campaign for Blue Walker 3. It's combining visual and telescope data. So it's all out now in Nature. You can see this is the main plot from the paper showing the brightness over time. You can see the green points are the visual observers, and the other colors are all the telescope data, and you can see very good agreement between the two and just how bright the satellite was. There's also other points like the launch vehicle adapter was also very bright and it was not tracked for the first few days. And there's also, we find that the TLEs are changing by about 0.4 minutes per hour in terms of accuracy of position on the sky over time, which is also important. So please do go read the paper that's out now. We also have ongoing observing campaigns if you're interested in participating in these. So the Starlink Gen 2 Minis were launched. They have optical mitigations with these Bragg reflectors. How well have they worked? We don't know yet. So we're trying to do an observing campaign for that. If you're interested in participating, do let us know. We're aiming to have a letter published on that by the end of the year. We also now are looking at the Blue Walker 3 and the International Space Station in sub-millimeter. So the thermal radiation from these satellites, because we don't know how thermally bright they are. So we've got time on Scuba 2 and JCMT. We're just starting observations with them. And hopefully, if that works, we'll then look at the fainter satellites as well. I'm also preparing for other campaigns in the future. So Amazon Kuiper is supposed to be launching on Friday. China is supposed to be launching satellites soon, and we want to be preparing for observation campaigns for those. So your participation in all of these and ideas for campaigns will be very welcome. Please do join the conversation on the Slack. And just to reiterate, if I've not said it enough, we really want engagement from everyone here. So if you can contribute, please do apply for membership if you're not already a member, and do join in the Slack discussions. And there's a QR code there if you would like to join now. Okay, that's the summary. Thanks very much for listening.
Thank you very much, Mike. So Mike and I, we're going to be around. If you have questions for setup, just grab us during the coffee break or join us in the hackathon on Friday.